Welcome to the how-to for formula weights, molecular weights, and percent compositions. Formula and molecular weights basically mean the same thing. They are the sum of the atomic weights of the atoms in the chemical formula of a substance. More specifically, we talk about molecular weights when we're talking about some type of molecular compounds. So, when we go to calculate formula weights or molecular weights, the first thing we have to do is convert the name of the compound, such as sulfuric acid, into its chemical formula. You see here that it's struck out, and the reason that I've struck it out is to show that you really need to make sure you know the nomenclature, because if I asked you how to calculate the formula weight of sulfuric acid, you would need to know that is H2SO4. Once you've done that, you can then set up a little table where you list all the different types of elements that are listed in that molecular or ionic compound. So we have hydrogen, we have sulfur, and we have oxygen. So we've listed that as hydrogen, sulfur, and oxygen. Then we can list the number of atoms. How many hydrogens were in the formula? Well, there's 2 of them, so we write 2 here. How many sulfurs? Well, there's 1, and there's 4 oxygens. We then can list the atomic weight of the individual atoms. Each hydrogen is worth 1 atomic mass unit. Each sulfur is worth 32.1 atomic mass units, and each oxygen is worth 16 atomic mass units. Meaning that we can take our 2 hydrogens times 1.0 atomic mass units each, gives us a total atomic weight of 2.0 atomic mass units. We can then do the same thing for sulfur, and then we can do the same thing for oxygen, and then add those up to get a total of 98.1 atomic mass units. Next, we could talk about the percent composition. And in these, this is the percentage by mass that is contributed by each element in the substance. And there's a general formula for it. The way I like to think about this is, let's just say that we had a basket of fruit. And in this basket of fruit, we could say that we have 1 banana, we have 3 oranges, and we have 6 apples. And let's say that each banana is 0.5 grams. We can say each orange is 2.5 grams, and we could say each apple is 3.0 grams. And if I asked you what the percent of oranges in the basket by mass were, we could calculate that, right? And in that case, we would say, okay, well, how many oranges do we have? Well, we have 3 oranges. How much does each orange weigh? Well, it's 2.5 grams. And then we could ask ourselves, well, what is the total weight of the basket? Well, the total weight of the basket means that we have 1 banana at 0.5 grams. We have 3 oranges at 2.5 grams. And we have 6 apples at 3 grams, which is 18.0 grams. And then we could add all 3 of these up, right? And so that would give us a total of 26 grams. That is our total mass. Then we would just multiply that by 100, and we would solve and find that we get 28.8% of oranges in the basket by mass. So that's the exact same thing when we're talking about the percent composition of each element in the substance. We choose whatever the number of atoms are of that element, the atomic weight of the element, over the total formula weight of the substance, and then multiply by 100. That is how to for formula weights, molecular weights, and percent composition.